All right, let's get started. What kind of drink can be hard to swallow? Hard. Reality. That was a good one. How did the hipster burn his mouth?
He ate it before it was full.
Yes. Man, nobody's gotten that one. That's awesome. How did the picture end up in jail?
It was framed.
It was framed. Good job. Okay. I was going through and I realized there was a couple of mistakes that I made with some of the video lectures. I didn't realize those lectures were not last semester's actually forgot to record those lectures. So they were from, another semester there. And I changed a couple of things, and it's all the content's the same, except for kind of the end. One thing I realized that I didn't even finish the error redirection. Was that true that I didn't finish that? I think that's what I saw. I told you I'd cover it later, I think on the last lecture, and then I gave you an assignment that focuses on error redirection. So some of you turned that in, but you have unlimited attempts on that. So what I think I'm going to do is I'm going to move that till like Monday. Will that work? I mean, it's very, very small anyway, but I apologize. I did not realize at the end of the lecture, I ran out of time and didn't cover that. So we'll start and cover that real quick. I also made a short list of announcements that I need to cover and then forgot them and left them in my office there. So hopefully I'll be able to remember it all. But for right now, we're just going to pick up on this and we'll kind of get through some of those other announcements later. So this is where we left off in the video, and it is on redirecting errors. So when we actually create kind of our own custom error messages, so you can see right here, I got this goes to standard out right here. And that is exactly what it's going to do. Every time I create an echo statement, it's going to send a standard out. But when we create our own custom errors, we don't technically want that going to the standard out channel. We'd like that to go to the standard error channel. So all we have to do to redirect that is we use channel 1, the redirection, and then we do the ampersand and then send it to channel 2. So that's all we have to do there. So now this is going to go to standard out, or sorry, standard error instead of standard out. What that helps is later on, if we're actually trying to capture, if there's any errors that occur in the script, and we want to redirect them all to a log file, so we could run our script and just redirect everything to like error.log. Then if there's any errors that occur, any of our custom errors, they won't go to standard out, they'll actually go to that log file right there. So this is going to be one of those things that I'm going to tell you now that you need to do. And the current assignment that I'm going to give you an extension on until Monday, that assignment tells you to do that. But that is the only assignment that's going to tell you to do that, because this is kind of just a standard best practice thing that you should do every time you write your script. So for all of the assignments after this one, I believe it's assigned 4, it's never going to tell you that, but you are graded on it. It's just kind of like the TAR commands. It doesn't, I grade you on that every single time. Also, I think we covered it. Did we cover exit codes yet? Got a lot of blank faces. We should have covered exit codes. Do I need to go over exit code? So when we actually create a custom error message and then we create an exit, and that exit would either be 0 or 1. Does that bring in? Okay, good. All right, so that's another thing in these scripts that it's not going to tell you to do that, but you need to know to do that. So when your script runs successfully and you get to that last step, it should exit with a 0. So status code of success. So you will code that in there at 0. At any point in time, you code in and kind of like a state where it's going to fail, then you would need to do exit 1 or exit greater up to like 255. But most people just do 1. It's kind of the standard. So anything greater than, or anything 1 or greater is an error, and 0 is the only success. So that's 2 things that you kind of need to add to your scripts every single time. You will be graded upon that, even though the script may not mention it in the instructions there. What you got?
Is that already going to standard out?
Yeah, it's not. You could do it without the one, just do the redirection &2, and that would work. All right, so here is an example of what a good script should look like. Of course, we got our bin bash, so it knows where to run it. Here is an argument. So this is actually the number of arguments. So if the number of arguments is equal to 0, then it's going to run this custom error message right here. It's redirecting that error message to standard error. And then because it is an error, we want our script to close at this point. Of course, this is only if this is an error that we want the script to actually exit out. Because it's kind of like catastrophic error. Like if you don't supply an argument and your script requires that argument for it to work, then obviously you don't want your script to continue running if somebody doesn't give that argument. So we need to do an exit one. The exit is going to cause it to exit out. And then of course the actual error message. So if it was 0, that means success. If it's 1, it's going to be an error right there. And yeah. And the one thing this one doesn't have in here, because it's such a simple example, it should have an exit 0 for success. I need to go in there and update it in here. So the exit 0 should come right here at the bottom of the script. Of course, this is just me running the script right there. All right, any questions before we move on? I think I forgot. Give me 1 second. I forgot to log into. Because we'll need that information. And while I'm in here, I'm going to go ahead and change that due date real fast so that need to be a little bit larger. So assign 4 here, I think we'll move it to midnight Monday. Does that work for y'all? Okay. Yeah, another thing I remembered, I will get to grading the actual exams. I'll have them graded by Friday. So maybe Tuesday we'll review them if I can squeeze that in. If not Tuesday, it'll be Thursday, but I think we'll be able to get to it. All right, moving on here. So this is just kind of a reminder about, there's 3 different ways we can kind of test a condition. So that is with the actual, kind of depreciated method of the test, the word test. And then we have like our single bracket and our double bracket. The double bracket supports all the mathematical operators and kind of the double ampersand for the and the or right there, more of what we're used to. And then I gave you a link right here if you kind of want some more examples on that. That's a good place to kind of show you the difference between the 2 there. All right, so we've covered echo. Now we're going to expand on echo here. So we've got this -E option. So if you supply the -E option, then it will interpret all of these slash commands. You can actually put them inside of the actual text that you're trying to echo. It will know that those are special characters and therefore will interpret them. Now, just -N option, it's simply a shortcut. You can actually recreate it with some of these slash options. But the -N is just a shortcut if you don't want there to be a return here at the end. So it won't create a new line. It'll just put everything on one line right there. And we can kind of see some of these examples real fast. So if I just said echo, we do hello. I'll tell you what, just for compare and contrast, we'll just then say echo world here. So if you do that, you can see they're both on the same line. But if I was to go up here and change this to, we'll do a -N here at the beginning. So that suppresses the new line. So you can see it's kind of connected. And then we've got kind of the problem of it not being 2 different words. So I could add a space in if I wanted to, or we could go in here and then I could do, we'll do the -E, and then I could say, okay, I want a new line here. And then I want a new line here as well. Now you can, need the -E. So now you can see I kind of got that. And then if you wanted it at the beginning, it doesn't matter. You can put it anywhere you want. Then you can see that you could, correct those spaces. So this right here just saves you a lot of time. I noticed like I think in assign 4 right here, you kind of had to have a space at least below. I can't remember if it was above. This would allow you to kind of add those spaces without having to just do an empty echo. just saves you a few keystrokes right there. All right, so I believe we covered the for loop so far. So now we're moving on to the while loops. Luckily, this is very, very similar. We just kind of have those keywords we have to remember. So this one would be while, then we have our do and our done. For loop uses the same thing with those keywords do and done. So again, just our test, what we're testing here. And then if it's true, then it's going to go ahead and execute the commands we have in here. And then you can see in here, I believe I know we talked about, how if you do the single brackets, how it has, it doesn't allow you to use those math operators. So -LT is going to be less than. So here we're doing, if this number is less than 10, then it's going to simply go in here and echo. And you can see we have the echo -N here. So every time it has the number that it's going to echo, it's not going to do a new line. So if we just went and / it didn't read with that one, wow.sh. So you can see right here, it's just going to have that space in there and do a new line each time there. And then down here, of course, we have the actual double bracket right here. And this is how I like to do it. I do all of my string comparisons using the brackets. And then I do all of my numbers right here using those double brackets. Of course, you also have the rule here can't touch, here can't touch. But if you use the double brackets, it doesn't matter if you put a space or not. You could just go with the general rule of always put space, and then you don't have to remember which one is which, because the double brackets, it won't error out if there is space there. And then here is just an example, and all we did right here was switch these two right there. So here you can see there's space, it works fine, no problem there. Here is the many different ways of incrementing variables. You can kind of just pick one and go with it. It's not depreciated. Oh, what you got? Did I not open it? Nope, it did not. All right, you should be able to refresh and that'll be available to you. Sorry about that. All right, so let allows you to do some math, but now we kind of have the updated syntax of these two right here. We will talk more in depth about when you will use the double bracket and when you use the actual $sign a little bit later. But one thing to point out right here is with these two right here, you can kind of do a postfix increment or a prefix. And if I got an example that explains it a whole lot better here. What was that? Somewhere bottom left-hand corner in the counter. So let's vim counters.sh right here. So I just got two numbers set up called the pre and the post right here. And then I'm telling you which one it is just so we don't have to guess. So this is the pre-increment. And then here is the number. And then if it's less than 10, so it's going to sit here and loop through it. And then again, I'm doing the same thing, doing a -N. But here you can see I'm doing the pre right here. And so it's inside of an echo statement. So when it's inside of the echo statement, what it's going to do is it's go ahead and going to give the number as is at that moment before it increments it. And then we can kind of see after right here, I'm referencing the same variable. So here it won't be changed because it's in the pre inside of the echo. And here it will be changed versus the post one right here. So in this echo statement, these two numbers will actually be the same because it increments the value before it actually evaluates it. So if we just run that, you can see here's the pre-increment. So the before it's 1, 1, and I said that backwards, didn't I? I apologize, because if it's pre, it's going to increment it before it actually evaluates it. And then if it's post increment, then it's going to actually go ahead and give the value. And then after the fact, it'll increment it right there. So, sorry, what? All right, thought somebody had a question. All right, so until is kind of the opposite of the while loop right here. So it's going to sit there and loop continuously until a condition is met right here. And I kind of created the world's worst video game as the example right here. Let's see, until So you've got this secret called whiz-bang and then a name with no value. And then it's just going to test to see when these two are equal. And again, we haven't covered this read right here, but it's just a way to prompt and get information. It's actually in the next lecture. And so until these two are going to be equal, then it's just going to keep on prompting me to make a guess right here. So if I was to do, what is it, until.sh, and then I just type my name or anything, it's just going to keep on asking that until we actually give it that secret, and then it'll be equal there. All right, so when we have for loops, we can use this break and continue within for, while, and until, and it will interrupt the normal flow of these loops right here. Now let's just bring up the example on it and walk through it. So we've got the them until break and continue. All right, so we walk through the code, we just got a variable called index. And then of course we got a sequence right here where it's 1 through 20. So that's kind of our set loop. It's going to count 1 to 20 there. And then we're evaluating that index. Of course, this is in double brackets right here. Now I went ahead and used kind of the old method right here. That's fine. So this is less than or equal to. And it's going to sit there and check if it's less than or equal to 3. And then if that is, it's going to echo continue. And then it has the continue that's actually triggered after this. So what that just says is I'm not going to process. If this is true, I'm not going to worry about processing this. I'm just going to go ahead and continue my loop. So if this gets triggered, then it's going to continue and go to 2. Of course, it evaluates to true here. It's going to echo continue, and then it's going to hit the continue keyword there, and then go back up to the loop again and just ignore all of this. And then we have a condition that's never going to get met, just kind of proving this one works, because we should be 3. Here it's saying if it's equal or less than 3. Of course, when it gets past this, it should be at 4. So this should never be triggered. And then we have another condition checking to see if it's greater than 8. Of course, at first, this is going to be false right here. And so it's just going to hit this echo right here because that whole condition, it's outside of that condition. So we should get continue, 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 and then 4, 5, 6, 7, and then 8. And then once it actually hits 9, this condition will be true. It's just going to echo break here. And the break is not going to, it's just going to break us out of the whole entire for loop. So we'll never get to actually 10 or all the way to 20 right there. It'll just break us out of the whole for loop. And then of course it's going to hit the echo here. So if we run that, you can see we got our 3 continues, and then 4 through 8, and then 9 hits. So it's break, and then it breaks out of that loop. All right, case statement. Case statement is really, really cool. There are some other languages out there that have similar things to the case statement. I like to use case statements when my if statements are getting like kind of out of hand, or my favorite time to use a case statement is if I have a major branch in my code. In other words, depending on what the user does, it could drastically change where my script is or what my script is going to do. The reason I like this is because it's so easy to read. So we just start it with that case, and then we have a test string, and we have to use some method to actually give a value to the test string here. And then it'll take that test string and it's going to say, okay, does it match pattern 1? If so, I'm going to execute these commands. But if it matches pattern 2, I'm going to execute this, and so on. And then of course, these are just our delimiters. They're for each single case that happens. And of course, we close the case with the reverse. It's kind of funny how we have if and phi, and then now we have case, and case spelled backwards. And yet the for and until and the while loop all have do and done. They, again, not keeping to a common theme there, but at least they kept this similar to the if statement. So one thing to point out is when we give this some type of value right here, it's not going to check and see, okay, does it match here? Does it match here? Does it match here? Then I'm going to run the code. No, it's if it matches, if it doesn't matches here, it skips. If the match is here, then it skips that one right there. So it's only looking for one match and one match only. Now, we can alter that. We'll actually see that a little bit later, but we have to integrate some more utilities to be able to do that. So here is a simple case statement. And again, I know we haven't covered it, but it's using read. And again, this is just a prompt right here, next lecture. So it's just going to prompt this to the screen and tell us to enter A, B, or C. And then it's going to capture it right here using this variable called letter. And then we actually reference letter right there. So that's how it gets the information to it. And of course, if we type in A here, obviously it's going to match there. It's going to enter that code and then break out right there. And so on and so forth with those. All right, so here is an example we can actually walk through with a little bit more stuff in it. So let's, forgot the name, case country. All right, so we got a read at the top here. And again, this is the variable that we're using. We're using an echo -n, so we're going to suppress that new line, and then it's just going to go ahead and put this on the screen. Of course, you're not even going to notice this because it's going to happen so fast, but you'll get the whatever country you type is going to be displayed, and then it's going to tag on whatever value or whatever echo statement gets triggered. It's just going to tag it on to the end right here, so it'll just be one single line when it's actually run. So here we have United States. Of course, if that gets triggered, then it's just going to be English. And then we have two options here, and we actually put them separated by a pipe. So that's kind of an or. So if it's Romania or Moldova, then we're going to get Romanian as the language. And then we have Italy and so on. Now, why do some of them have double quotes and some not? Why do you think I did that?
Because there's a space.
Perfect. That's simple right there. Now, should they all have double quotes around them? Yeah, technically, if you want to be explicit, it would be a best practice to put double quotes around the reading all of them. But I'm just showing you, you don't have to. It's not going to error out. And then we'll cover some of these special characters, but the asterisk is just a catch-all. So if there's no match whatsoever, then it's just going to echo a default statement there. So let's go ahead and run it. / country. And so if we did United States, then you can see it's going to trigger that. Run it again. Italy. You can see it's going to trigger that one right there. And then of course, if I give it some junk, oh, well, actually I need to run it and give it some junk, then it triggers our catch-all there. All right, so here's a breakdown of kind of those. We have our catch-all right here. The question mark will just match a single character, and then we can give it a range with a hyphen there. So you could say 1 through 8 if you wanted to, and it would catch that. And then of course we have our pipe right here, which separates, kind of creating our ors. Yeah, I want to cover this one right here real quick and show you all a little trick. Let's do Vim case low. All right, so in this one, I kind of shrunk it all down, showing you can put it on a single line. And also on this one, you saw like I had to type it exactly. So the United States started with a capital letter. Here, I'm going to fix that problem where it doesn't matter what the user types, that will catch that. So same right here, read right here, and we have our echo statement. We talked about this on some of the name variables before. So reply is a special variable in the background that captures whatever a user actually types in. So I didn't have to actually put in a custom variable right here because the user was just going to type one thing. It doesn't matter if it's a long sentence, it could be multiple words, but it's just one instance of it. It'll catch whatever they type. And so I can use that and then just echo reply. So whatever I type gets echoed out. And I don't think, have we talked about the triple arrow before? Okay, cool. Let's do this. So we have this arrow right here. Somebody tell me what that does. Yeah, I heard it redirects to standard out. What if I double it? Appends to standard out. This is important in this case. What about that one? Oh yeah, so it sends whatever file that we put there, it's going to send that to the utility as standard in to that utility. So let's prove that. So if we did cat command, sync. Well, we'll just echo some text here, redirect it to file 1. I'm always so clever at my naming files. So if we did cat and then we reference file 1, then we get some text. Now watch this. So if I was to say, let's do a redirection of a string, let's do some string and then hit enter. And look what we get. Some string, no such file or directory. Well, let's do some investigating. We can actually prove why that is taking place. So if we look at cat right here, it expects options and then it expects what? A file. Was that a file? No, it was a string right there. So we've got to figure out a way to get around that restriction. So the way we can do that is we could say cat, we'll just bring that back up. And unfortunately, the double arrow doesn't work because we will talk about that. That is a reserved for what is called a here document. So it's not available to us. So they added that. So it's triple arrow. So use triple arrows whenever you have a string. So now you can see that even though this expects a file, the triple arrow basically turns it into a temporary file to send it to it. So this is a string. And of course, what are variables? When you run the variable, what are they evaluated to? A string. So we can prove that with, we did cat, and then we can do, well, let's do this, host name, hit enter. So now you can see host name evaluated to a string, and then it was sent to the cat command as a file, and it read it real fast. So perfect. Let's go back up, get back into this one. All right, so that's all I did right there is I have country. That's my variable. I'm setting it equal. And since, you know, what is country? What is it expecting as its argument? A string. Okay, so this obviously is not a string, right? So I put it inside command substitution, just like we do inside an echo statement. So we have, you know, the command substitution taking place right there. Then I just did TR, and I'm translating all the upper characters to lower characters, and then I'm redirecting that variable contents into TR because TR expects a file. So works perfect that way. The other way of doing it is you could use command substitution here. I'm just echoing out the variable, piping it to TR. This way, I just like this way. To me, it's a little bit easier to read and understand what's going on, and it's a little bit less code right there. So that is going to then take whatever the user types and put it to lowercase. And then now I've moved everything, all of my evaluations to lowercase right there. And you can see I then put in my echo right after it, put in my delimiters right here between each cases, and kind of shrunk it down all one line. When I start writing larger code, I love this right here because I can put in whatever condition, and then I just call function. And man, it just makes it so easy to read all the code right there, kind of the branches that are taking place. Select statement. This is one of those things that I'm going to teach you, and don't ever use it, at least in my class. I do not like them. I use them very, very rarely. It just creates a quick and dirty menu. If you just want something, if I'm going to actually make something that I want to be out there, I would code my own menu. And it would look a lot better. But select allows us to create this numbered list. And what it's going to do right here is we have select. We give it some variable to collect the information, and then we give it the keyword in, and then here's our menu right here, apple, banana. So you're going to have 1, 2, 3, and then 4 right here. And then here we're just capturing, if you give it nothing, then we're going to say that's an invalid entry, and then it's going to continue back up to the loop because this does create a loop by default. And then here we're catching a way to break out of it, because this thing is just going to loop continuously unless we actually code our own way out. Of course, we say stop, and then if it stops, we're using the break right here. So it breaks out of the select statement, and then it's just going to echo what we actually choose. So you can see I got 1, apple, banana. So if I just click that, it's, you know, again, it's going to loop right through it right here. And here's my code. So if I do 2, it's just going to sit here and do those until I hit 4 and then break out of it there. And then I think it's on the next slide, but I'll go ahead and cover it. So let's see, no, we'll open it up in VM. Select PS3. So I've told you we can use like the prompts here. Let me bring that down so it will be out of the way. So this thing right here, when it actually was asking us for the information where we entered it, that was the PS3 prompt. So in here, I just changed the PS3 prompt to enter your selection. And then of course, it's the same code right there. So if we run it, then now you can see instead of that generic prompt that we got like right here, the pound question mark, it actually gives the user some feedback and I'm not having to code that in. I can just manipulate that PS3 prompt. Now, when I exit out of this script, is this going to affect my PS3 prompt? All right, I gotta know. Can someone tell me why? What you got?
Because you're running that in its own little subshell, right? So once it's done, it's not going to go back up.
Perfect. The child can't pass to the parent, right? So it's not going to know that we changed the PS3 prompt because it can't relay that information to the parent there. Good job. That was the PS3 prompt. Okay, I told you we're going to see it all throughout the semester. You'll kind of get tired of seeing all the different variations, but it's those curly braces. So all this is, it's a variable right here, and we're evaluating the variable. But now, if we throw it in these curly braces allow us to throw in some additional characters that have special meaning. I think, what was it? The colons with the numbers after it was string splicing. We had that on the last exam. So here we're throwing a pound sign in front of it, and that is just going to get the length of whatever we type. Now this is overly done right here. I'll explain that in a second, but here we just have a variable. There's the value right here. We have another variable and we're getting the value, the length of this variable up here. So it's just going to return a number to var length, and then we're echoing that string out, and it will have the number right there. So we'll get 46. Now, if I was doing this, I would just, wind up doing the curly braces here with the pound. That's kind of an additional step that's not needed, but it's just kind of showing you each step as it is there. Of course, if you need that number somewhere else, then that would be a perfect, time to use that. All right, and the shift. So I think we covered shift before in the previous lecture, right? And I gave you a really bad example of when to use shift. Yes, no, yes, okay, good. All right, so here is the good example of when to use shift. So here we have kind of an error, and I haven't updated the syntax right here. So what's missing from this error? Yes, so we could do one, the redirection arrow, then the ampersand that I'm terrible at, and then 2 right there. Just some places I haven't called up with all that. And then of course we have our exit code, so that's good. So it's checking to see if the number of arguments is less than 1. So this script needs some type of argument, so it's making that check. And then here we kind of have this little shortcut we can do. So $pound is the number of arguments. So we're basically boiling this down to like a true false. So if this value, or if this $pound has a value, so that means we do have arguments that are being supplied, then it will evaluate to true. And then when it runs out of arguments, then it will evaluate to false. So then we break out of the loop. So it's just kind of a shortcut to do that right there. And so while there's arguments, it's going to echo file name $1. So it's going to echo the very, very first argument that is given. Then it's going to call shift. So if we take a look at this example right here, so here we're calling the script, and then here we have, 4 arguments being supplied there. So once it hits 1 right here, of course, this right here will be false because we have arguments, so we don't have to worry about that one. And then it hits our while loop right here. So while the number of arguments, so that's true, it has the number 4 in there. It's going to echo out $1. So it's going to echo out 1. And then when the shift happens, it's going to knock 1 off of the stack. And now this becomes 1, 2, and 3. Then of course it's going to loop right through again. The new $1 would be 2. It's going to knock that off of it. And then we have 1 and 2, and then it's going to keep on doing that, of course, until there's no more arguments, and then this will evaluate to false, and then it breaks out of the loop. Wow. So right there, no argument, so it caught it. And then if we do 1, 2, and then we'll 3 and 4. Now you can see it just catches each one of them, and then it ran out of arguments after the last one.
Does it ever catch the min followed? You argument 0?
No, it will only look for 1 and greater, not $0. That answer your question on that? Yeah, so it'll never trigger the shift right there. It'll never catch the $0, which is just the name of your script. All right, at the end here, I think I have this in there, but this is just kind of reminding you. So here are things that I'm going to always be grading for when it comes to scripts. I don't like this top part right here. I don't care if you put that in your labs. Your labs are more for your benefit. If you don't want to sit here and type all of this right here, I'm fine, because you're just creating script after script after script. But in your actual assignments, that you do, of course, you need to have that. Even your scripts or your labs will have to have that. I want your first and last name, the date that you wrote it, and then the actual assignment name in there. And then comments. You need to be able to explain what you're actually coding. If you do not, you're going to get docked every single time that you do not write comments explaining your code. Of course, then we have our exit status right here. Every script, when it ends with a success, it should have an exit 0. And of course, understand, depending on how you code it, the success could be in the middle of your script. Or it could be at the very, very end of your script. There are some people that I've, graded, and they love nesting a whole bunch of if statements, and the success will be right in the middle of that. I don't tend to code that way. Most of mine end at the end with success, and I kind of code all the exceptions in, the if statements there. And then, of course, the actual redirection of those errors right there. And now here is some best practices. I don't know if I covered this because I gave you those videos. This right here just forces your script. If there is ever any type of error, then it will just break and exit out. So it's a good way to test if there are errors, because there can be errors that actually occur that don't trigger something catastrophic and you don't see them, but they are harming. Now, understand that you don't want to use this all the time. I'm trying to think of a project. I think we have one here, but there are several scenarios. I'll give you an example later on where you're going to want an error to occur. And you're going to handle it yourself. You're going to hide it from the user, but it's very important that that error actually did occur. And then we could branch our code on that error, check for the actual success or failure using the status code of that, and then branch our code from that status code. So if you were to put that at the very, very top of your script, then that's not going to work, because it'll kill your whole entire script. So this is right here. It's not a requirement. It's for you. It's kind of like a tool for you to use. And then I'm just giving you naming conventions right there. I'm not really going to grade. These are best practices. These are things I'm not grading on. I am grading on this part right here. But of course, if it's local, it should be lowercase. If it's global variable, then uppercase right here. And then I can't remember. Oh yeah, just the importance of the double quotes and stuff, because that can actually change how those things are interpreted if you don't do them correctly there. And then at the end, I'm giving you just a good example of, a script right here, what it should look like. Of course, right here, my success is at the bottom, so I'm ending with exit 0. Here is a failure, so I want to end with an actual exit code. I'm using my redirection for all of my errors there. I'm commenting my code, and I got the block up here at the top there. So all of those things you will be graded on. All right. Did I cover anything about like a shortcut, writing a function or a script to actually create scripts? Did I cover that? Okay, good. If I did, ignore all of it because I changed it. So we're going to cover this. And if you want it, I think it's actually in here. Module 8. And we have, no, I'm in the wrong module, aren't I? 9. Nope. Did I put it in 9? Yeah, I added it to the wrong one. I'll fix that after class here. And I just, well, what? Oh, I already have it. That works. No need of copying. All right, so here I just created a text document, and then of course I named the text document script maker. It's the same as the function, but I just pasted a function inside. So here's our keyword, and then here is the actual name of the function, and then here is the function code. This is very, very useful because you're going to be creating a whole lot of scripts, and this kind of just lays out the blueprint. It also will put the correct permissions on it. So a function takes arguments, so we're going to take advantage of that. And now I have an echo statement right here, and I'm just echoing out a shebang. Of course, I'm redirecting it to the first argument being supplied to the script right here. And so it's going to create that file if it doesn't exist. So whatever name that I give after the script, it's going to create a file with that same name. And inside that file, the very, very first line is going to be the shebang. Now I'm going to go down here and I'm putting my name. You would obviously put yours. And then why the difference right here in the redirection? All right. What happens if I would have put just a single? Exactly. It would just be overriding and I would never get anywhere, right? So here I'm just doing my name. Here I have the date, and then I have an assignment. And then here I'm doing /n/n. So what is that doing? Yes, I'm just putting new lines after it instead of doing echo after it. Well, actually, it's going to do a single line because the -e doesn't create lines, so it's doing just a /n afterwards. And then the second one would just be a new empty line right there. And then I'm doing the same thing right here, just as a reminder that I need to make comments. And then I'm putting an exit 0 here. So that right there should be at the end. So it's going to have a space there, just reminding me that I need to put in exit codes. And then what's this doing? Changing permission. So what permissions is it given? Say that again. To the owner. And then what does everybody else get? Perfect, perfect. All right, so let's test it out. So I need to source it first. So if I do script maker, and again, you can write the word source, or you can put a period with a space and then the argument, and that's the same thing. So now I've sourced it. Matter of fact, we can do declare -f, and we should be able to see, here it is, right in memory. So now let's go ahead and run the thing. So I should be able to apparently there's another thing called script in there. So I got to actually do the M. So it picked it up. It's reading it there. And then we can just give it, we'll just call it script.sh here. Hit enter. Now when I do an ls-l on it, if we look through, where is it at? Script, what did I name it? Script.sh. Yeah, right here. So perfect. It's got read, write, and execute permissions, read, and then read, and everything's executable. So now if I was to cat it out, actually we'll open in Vim so we can actually see the color codes. Script.sh. Now you can see it's got my shebang up there. It's got my comments right there. And I see a mistake that I made. That actually should have pound signs in front of it. Let's script maker. So yeah, you should go up here, and like I did it on the shebang right there, but just go ahead and put a pound sign in between each one of those. I'll update that and add it to this lecture right there. So that way it'll actually be comments there and for each one of those. And it's funny, I did it to that comments, but just wasn't thinking on it. Escape. All right. Any questions with that? So that's very, very helpful in those labs, right? Now you can just quickly get through all that stuff, and it'll actually even have the header if you want it. Of course, you can make a custom for labs or assignments, however you want to do that. All right, now, yes, your homework assignment. Where's it at? There it is. Okay, y'all did really, really well. There was just a couple of things that kind of happened that I'd like to point out. Of course, the main, this right here, obviously not required. That will just get ignored when I source it because there are comments right there. So I just like to put it in there. There was no need for an actual shebang. Why not? It's a function, it's not a script. Now, there was a few of you that kind of got confused on that, put a shebang, but again, it's not required. Of course, we just learned right here that we could have do like an echo -E and do the /n. So we could put a /n before it and a /n after it. And then we shrunk those 3 lines down to actually 1. Here, it didn't matter what you did on this. Well, I mean, who am I requires you could have actually done, I think user. That would be a variable. So you could have done just $user and you wouldn't have to use command substitution. In this one, I used the variable host name. You could have used the command host name, which is all lowercase. So that would have been command substitution. I believe you Mac users, $host name doesn't work, right? Yeah. Okay. So you would therefore have to use the command host name on a Mac versus Linux right here. In this one, I just simplified things right here. I created a local variable. Again, in the terminal, it's local by default, but when you're in a function, even in your scripts, those are all local by default, but within a function, the scope is the opposite. So I created a local variable called format, and I just gave it this right here. So therefore, I could just echo format each time and didn't have to sit there and write out all of, you know, that mess there, the little separation. And then, let's see. Some of you did -U here and then gave it a name. Of course, you couldn't give it your name. You had to use some type of either variable or command right there to get the person that's actually running the script. Here, this one right here actually did grep right there, but you could have done like ps-fu and then did the command or the who am I command there, and it would actually get the same thing as well. The only difference between, and I didn't care which one you used, if you use the -U will get you additional information. In other words, this one right here, it will only do your current bash shell that you're running, but there are actually some other, well, we'll just do this. PS -F. So this one right here is just my current shell, but if I was to go in here and do -U and give it J Corcoran, you can see that there's actually some other shells that I have information running on. So this is a little bit more thorough if you use the -U option, but again, I didn't require it in there. I just required that it be in the long format to get that additional information, and the UID here was only your user ID. Another thing a couple of you had trouble on, and I wanted to address that, was, let me open this back up. I hate that that thing will not go away. There we go. Some of you didn't put echo statements in here, and I kind of get like some of the thought on it. Let's see if I can give an example. Well, I'm going to just do hello world here. So if I do that right here, it would actually, especially if it's just something single like hello, you can see you might have gotten that, but understand that it's thinking this is a command. And then if you use, even if you used a variable in here, so let's just say, we'll just test equals, yeah, date here. So now if I actually echo out here, or no dollar, yeah, test will get evaluated and it will run as date right there. So understand, like, the echo is interpreting how it gets displayed. So the fact that this is just a string right here, and then once the shell interprets it, then it just prints date out there. And of course, we know if we do date, then it's going to interpret it as a command. So don't get confused on that. Make sure if it needs to be an echo, put the echo in front of it, because what would happen is a lot of stuff would just, it actually have the true value there, but then it would have command not found after it. So it did display the information, but again, it's not exactly what you wanted because it had errors with the command not found. So all of that would have been actually on the standard error channel versus the standard out channel. Another thing that happened was, let's see, PS-F here. So maybe we do E so we can get a lot of information right there. If you were to put, say, echo, that look the same? That's really messy, right? So this right here ruins the entire format of the output. So that's why you got counted off on that, because you can't read that right there. And understand that if you can put a command on the command line by itself, there's no need to put it in command substitution, because every single line of that function is a line on your terminal. It represents this line right here. So if I don't need an echo, if I'm not trying to add to it, then I should just do PS-EF here. And then not use the echo. You only use command substitution when you're being forced to do so. Now, there are some workarounds you can do to actually get the formatting correct, but again, that's just something else you have to remember, and there's no point in doing it. You're just adding code for no reason. So make sure that you use that appropriately. Always resort to the command. If it's just a command, what you got?
What's the name?
PS command. Okay. So the PS command is, again, it has access to everything that's running on here. Now, the jobs command, you can see that there's nothing on here. So all the jobs is going to track is what I have currently done myself after the shell has loaded. And then it allows me to control the foreground processes. All this is kind of, it's all system background processes right here. It's not anything that I have actively done myself. So if I did jobs and had a bunch of jobs here and I spawned, like if I did bash and spawned a new shell, then this one's not going to know anything about that. It's just that single shell allows you to control the foreground, and you can put things to background. So you can say it controls the foreground and background processes that you are actually running yourself on that. So if I ran a job that I put in, there are ways, and we may get into that, where I can run a job and detach it from my current shell. And what that allows us to do is, if I close that shell, it's still going to run. But once I detach it from that shell, the jobs is never going to know about it again. I would then have to use my processes to be able to kill, pause whatever I want to do with that job or process here. Does that help? Any other questions? I think that, again, I will move that script afterwards. And let's see, we have a quiz to take. Just making sure I covered everything because I forgot my notes. I think we did it. And I moved the assignment to Monday, so we're good there. All right, let me get this quiz open for y'all. Should be quiz number 3. Make it available. Edit the test options here. Oops. That password, of course, you can open it. You don't need Respondus or anything in that. Once you are done with the quiz, you are good to go. Oh yeah, and there is a lab associated with this one, but no assignment on it. Which worked out perfect because I gave you all the extension on the other assignment. So you do have an assignment out there if you haven't completed that. Oh, and real quick, and y'all can just do this as a talk. I noticed there's a trend of everyone completing, or the majority of the class, only a handful completing it before the due date. And most of the people are completing it at the very, very last second. And that works right now, but understand, for the most part, each one of these assignments get bigger and bigger and bigger. And that will be a bad option for you if you continue that trend as we go throughout the semester.